I think we ought to find the equation of a line that's tangent to this curve at that point. Now, let's just be real honest. This is not a function, right? Right? Because we have y squared and y, and good luck getting y by itself on that one. And even if you do, you're going to have something that doesn't graph as a function, okay? So we need to take the derivative of this. Why is that? Because we want the equation of a line that's tangent to it. So before we ever really get started, let me throw a marker on the floor, but that's okay because I don't like that marker anyway. Let's just go ahead and deal with the fact that this is what I have to do. This is the equation of a line, right? So I need a line tangent to a curve. So I'm going to need a coordinate. So -1, 4, good so far. Y minus 4 equals m. Ooh, I don't know what m is. We'll find that. That's where the derivative comes in. And so x minus -1, so there's that. And we need to figure out what m is. So we're going to pause this idea while we find the derivative of this at the point -1, 4. We'll plug it in, we'll finish the problem, okay? So let's take the derivative of this, and as we do, we're going to go one term at a time. So we just did this process, but we're going to rewrite it a little bit. Let's do the derivative with respect to x of y squared plus 4xy, and then the derivative with respect to x of this side. Technically, I need to take the derivative of both sides instead of just saying I'm taking the derivative of the whole thing. It's a little mathematical thing. So we're going to take the derivative from left to right, right to left, however you want to do it. I'm going to go left to right. So the derivative of y squared is 2y. But because this is an x and this is a y, because the variables disagree, because of the chain rule, we have dy dx. And then we're going to take the derivative of 4xy. What? Okay, product rule. We're going to have to use the product rule on this one. And the product rule will involve letting 4x be f and y be g. And we're going to do f prime g plus f g prime. Okay? So let's keep going. F prime, the derivative of 4x with respect to x is 4. And it was positive. Times g. Well, g is just y. Okay, now don't be like, oh, but it's y, but there's an x. No, 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 no. G. Just g, not the derivative of g. Plus f, 4x. Oops, x. Let's fix that. I said x. G prime. Now we're going to take the derivative of y with respect to x. And the derivative of y is 1 dy dx. And that is equal to the derivative of 3x squared, which would be 6x, the derivative of -3, which is 0. We are now going to solve this for dy over dx, and that's going to give us our derivative. So let's move the 4y to the other side. So we have 6x minus 4y. And on this side, we're going to have 2y dy dx, 4x dy dx. Let's factor a dy dx out. Now, again, this term is gone. We're doing a lot of steps at once, but this term is now moved. But these two are still there. You might say we could factor a 2 out as well. I don't disagree with you. I just choose not to do it right now. 2y plus 4x. There we go. And we're solving for the slope, right? So the slope, dy over dx, equals 6x minus 4y over 2y plus, what kind of plus sign was that? A little wavy thing. 4x. There we go. Fantastic. Now we know the slope and the, we don't. We don't know the slope because we still haven't plugged in the coordinate -1, 4. So we need to know the slope at a specific point. So let's go a little crazy on this. We want to know the slope at a specific point. That's what the vertical line is for. It says I'm going to evaluate it at some specific place, some specific x value, y value, x and y value, whatever. -1, 4. So I'm going to plug in -1 for all my x's. All my y's become a 4. So 6 times -1 minus 4 times 4 over 2 times 4 plus 4 times -1. Okay. -6 minus 16. -6 minus 16 is -22. All right. 8 minus 4. That's going to give me, well, 4. We'll call that what it is. That's -11/2. Okay, we found our slope. We found our slope at that specific point. I'm going to double check my work here. I have it worked out. Yep, that's what I got. Okay, so -11/2 is my slope. It comes over here. Oh, let's stick with the same color. Let's go with blue. negative 11 halves. You can stop here, actually. You don't have to go any further. You found the equation of the tangent line. If they would have said, use your tangent line to approximate the you may want to stop it for a while. But we could actually stop. Keep going if you want to. I choose to stop with that one.